We're going to look at solving proofs from scratch, and one thing I want to point out is that a lot of the times there's more than one way to complete a proof. So I'm going to basically provide one option, and if you see another way of solving it or completing the proof, as long as it follows logically and the reasons are sound, your proof should be fine. Okay, so a couple of things that I recommend when you are working on proofs from scratch. The first thing is mark your diagram. If there's not a diagram, make a diagram. Be sure you address all given information. That may be just in the given statement, or it may be that you're told something that you need to apply later in the proof. Okay, so let's look at this first one. I'm going to mark my diagram because I have a diagram and I've given some information. I'm told that segment AD is congruent to segment AB, and that segment DC is congruent to side BC. And this kind of gives me a clue as well as what I need to be looking at. I want to prove that triangle ADC is congruent to triangle ABC. Now, our choices for theorems: side, 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 angle, side, hypotenuse, leg, angle, side, angle, and angle, angle, side. So the first thing I do is I look and see which theorems are not going to help me. I have two sides, so that means hypotenuse, leg, angle, side, angle, and angle, angle, side are not going to be an option. Then I look at the two individual theorems. This one, I need to know something about the included angle. Remember, the included angle is formed by the two congruent sides. So I have this side and this side. The included angle is D. Over here, the included angle is B. Notice I don't have any information that will give me a clue as to whether they are congruent or not. So that throws that one out. So I know I'm going to do side, side, side. In order to have side, 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 since I have two, I need a third side. And notice we have a shared side. And shared sides are always congruent to themselves. So then we start the proof. Here's our given. Our shared side is congruent due to reflexive property. And then we have congruent triangles because of side, side, side. Okay? So now we're going to apply those steps for example 2. So we start with what we're given. AC bisects angle DAB, and angle 1 is congruent to angle 2. So I'm going to mark my calendar, mark my diagram. And then I'm going to look at this right here. What does bisect mean? Bisect means it makes two congruent angles. Okay? So that means angle DAC is congruent to angle BAC. Okay, that's from my given. And I have to put that information somewhere in my proof. All right, so I have two congruent angles, and I have another pair. So I have two pairs of congruent angles. So again, I look at my theorems for congruency, and the only two that contain two angles is angle, side, angle, and angle, angle, side. So now I'm going to look at my diagram again. I want to prove that triangle ADC is congruent to angle ABC. Again, I don't have any information on these outside sides, but I do have, once again, a shared side. That is congruent to itself. Notice it is between the two angles, so I'm going to use angle, side angle. That is the direction I'm going to go. So we start by filling in what we're given. Segment AC bisects angle DAB. And angle 1 is congruent to angle 2. This is given. Okay? Now I'm going to apply this given statement here. Because AC bisects this angle, I now have two congruent angles. Angle DAC is congruent to angle BAC. And we are applying the definition of bisector, in particular angle bisector. Then we observed that we had a shared side. AC is congruent to AC by our reflexive property, giving us our two congruent triangles by angle, side, angle.